Now preparation of K2Cr2O7, that is potassium dichromate. Preparation of KMnO4, that is potassium permanganate. Last lecture we have studied these two preparations. Now as usual, the next part is chemical properties. Now physical properties of K2Cr2O7 and physical properties of KMnO4, they are just theoretical things. Read them and make their notes, because melting point, boiling point, solubility product and all that things you have to study that. Now we'll start with chemical properties of potassium dichromate, and in that chemical properties, first we have to study potassium dichromate. If it is kept in acidic medium, what is the effect of acid in potassium dichromate? Now here Cr2O7 2 minus, it is nothing but K2Cr2O7 plus 14H plus, that is acidic medium in presence of protons. All these things are in aqueous medium, and for this exchange we need 6 electrons. Means Cr, that is chromium, here it is in +6 oxidation state, and in the product chromium changes to +3 oxidation state. Because of this, for each chromium you need exchange of 3 electrons, and therefore for 2 chromium there is exchange of 6 electrons. As a result of this, for the reaction which is carried out in acidic medium, we need exchange of 6 electrons, or there is exchange of 6 electrons, and water will be obtained as a byproduct. Now the proper reaction, actual reaction, the above reaction is called as ionic form of the reaction, and here the actual reaction is written: potassium dichromate in presence of sulfuric acid, there is formation of potassium sulfate, then there is formation of chromium sulfate, and the most important part of this reaction is that there is formation of 3 moles of nascent oxygen. Nascent oxygen formation, or any nascent element formation, that is most important because it is highly reactive and it will convert, it will get added in the required unit. This is your reaction, that is dichromate reacts in acidic medium. लक्षात काय ठेवलं पाहिजे? Exchange of 6 electrons. 6 electrons are accepted by dichromate to produce chromium +3. Dichromate undergoes reduction itself, therefore potassium dichromate in acidic medium is good oxidizing agent. It supplies oxygen to the suitable acceptor. Now these are certain examples which proves or which explains how potassium dichromate oxidizes given units. Now here we have written Cr2O7 2 minus, K2Cr2O7 is आहे, dichromate ion असा आपण याला म्हणूया. Its color is orange. This dichromate ion, when it is treated with H2SO4, that is acidified dichromate, आठवत असेल तर आपण याला या दोघांच्या रिएक्शन मुळे नेसंट ऑक्सिजन प्रोड्यूस झालेला होता, तो आहे याच्यामध्ये, आणि Fe2+. आता when any species is in its lower oxidation state, आपण त्याला म्हणतो रस, म्हणजे ह्याचं नाव आहे फेरस. इथे SO4 असेल तर FeSO4, त्या कंपाऊंडचं नाव होईल फेरस सल्फेट. जर क्लोरीन असेल FeCl2, तर त्या कंपाऊंडचं नाव होईल फेरस क्लोराइड. तर इथे dichromate, when it is treated with acidic medium, 3 moles of nascent oxygen are used here. Ferrous ions are to be oxidized and therefore they are introduced here. +2 changes to +3 here. बॅलन्सिंग करणं अतिशय सोपं आहे. याच्यामध्ये डोक्यात ठेवायचं आहे की 6 इलेक्ट्रॉन हे युनिट मला सप्लाय करणार आहे. आता Fe+2 कन्वर्ट टू Fe+3, म्हणजे each ion needs 1 इलेक्ट्रॉन. पण माझ्याकडे तर एकूण 6 इलेक्ट्रॉन्स आहेत ह्या दोघांच्या कॉम्बिनेशन मुळे, and for that purpose 2+ changes to 3+, such 6 units are required for the reaction. अतिशय सोपी स्टेप लक्षात ठेवा, डोक्यात ठेवलं पाहिजे. there is exchange of 6 electrons. पहिलं एक्झाम्पल होतं when ferrous changes to ferric. आता सेकंड एक्झाम्पल बघा. इथे मी K2Cr2O7 डायरेक्ट लिहून घेतले. Cr2O7 2- दिलं असतं तरी चाललं असतं. when it is treated with Ki म्हणजे आला potassium iodide. in Ki oxidation state of iodine is -1 and this Ki is treated with acidified dichromate. परत आठव, exchange of 6 electrons and liberation of 3 nascent oxygen atoms. As a result of this, products are common. Reaction पाठ करायची कुठलीही गरज नाहीये. Products are common. Product असणार आहे K2SO4 जो की वरती पण होताच. Product आहे Cr2SO4 thrice जो की आपल्याला ह्या दोघांच्या रिएक्शन मुळे मिळतोच. 7H2O बाय प्रोडक्ट असणार आहे. वॉटर विल बी ऑब्टेन्ड आणि सगळ्यात महत्त्वाचं आहे I- चेंजेस टू I. रिएक्शन खूपच महत्त्वाची आहे इथे. I- गेट्स कन्वर्टेड टू I याचा अर्थ होतो ऑक्सिडेशन स्टेट ऑफ आयोडीन चेंजेस फ्रॉम -1 to 0. If oxidation state changes from -1 to 0, there is loss of 1 electron or there is decrease in negative charge. Decrease in negative charge or increase in positive charge is called as oxidation. Therefore, when potassium iodide is treated with acidified dichromate, there is formation of iodine and this reaction is again oxidation reaction. Now the third reaction is action of acidified dichromate with H2S. H2S म्हणजे तुमच्या लक्षात आलं असेल हायड्रोजन सल्फाइड गॅस H2S. आता when this H2S in aqueous medium, it is passed in water in aqueous medium. You must keep in mind all these things are in aqueous medium. When this acidified dichromate is treated with hydrogen sulfide, when it is passed, again same products K2SO4, Cr2SO4 thrice, 7H2O, no change at all. You must keep all these things in mind because they are same products. Only the change is that this H2S changes to S. H2S. In H2S, oxidation state of sulfur is -2. In H2S, oxidation state of sulfur is -2. And in S, it is in free state. Therefore, in S, oxidation state becomes 0. Therefore, change in oxidation state from -2 to 0. Of course, it is called as oxidation because it is a loss of 2 electrons per unit sulfur. आता बॅलन्सिंग पण तुम्हाला कळेल. मगापासून आपण बोलतोय की if we use acidified dichromate, 6 electron exchange will take place. 6 electron exchange. One sulfur can lose 2 electrons. Such 3 sulfur atoms are used. 3 into 2, it will become -6 and therefore 6 electron exchange will take place when we use 3 units of H2S. बॅलन्सिंग एकदम सिंपल आहे. तेव्हा एकदा सगळ्यांनी ह्या 3 रिएक्शन्स बघून घ्या. पहिल्यांदा मी काय बोलले ते आठवण करून घ्या. आपण 3 एक्झाम्पल्स बघितली. ऑक्सिडेशन ऑफ फेरस टू फेरिक, ऑक्सिडेशन ऑफ आयोडाइड टू फ्री आयोडीन आणि तिसरं बघितलं ऑक्सिडेशन ऑफ H2S टू S. आता ह्या 3 रिएक्शन झाल्यानंतर आपण एक लास्ट रिएक्शन बघूया ज्याच्यामध्ये आपल्याला बघायचं आहे ऍक्शन ऑफ acidified dichromate on sulfur dioxide SO2. आता in sulfur dioxide you can observe that sulfur is with oxidation state +4. आता ऑक्सिडेशन स्टेट कशा काढायच्या हे आपण बरेचदा बोललेलो आहे, त्याच्यामुळे तुम्हाला माहिती आहे की -2 वाले दोन ऑक्सिजन आहेत, they become -4 and therefore sulfur becomes +2 each, म्हणजे -4 झाला, +4 झाला sulfur. Now this SO2, that is sulfur dioxide, gets changes to SO4, that is sulfate. In sulfate, sulfur shows oxidation state of +6. Sulfate always, sulfur is in +6 oxidation state. And therefore, these 4 reactions were studied in which potassium dichromate in acidic medium behaves as oxidizing agent. Now, for K2Cr2O7 and dilute H2SO4 in acidic medium, it can also used as oxidizing agent when alcohols are to be oxidized into different oxidized products. Means, for example, I will explain. If I have primary alcohols, now primary alcohols are the compounds in which OH, that is our functional group, is directly connected to a primary carbon. Primary carbon is the carbon which is directly connected to only one other carbon. हा माझ्याकडे आहे primary alcohol. When this primary alcohol is oxidized in presence of K2Cr2O7 and dilute H2SO4, when this primary alcohol is treated with acidified dichromate, जो लक्षात येईल हे जे दोन हायड्रोजन आयटम्स आहेत ते दोन हायड्रोजन आयटम्स हा ऑक्सिजन ॲब्सॉर्ब करेल, मीन्स इट विल बिकम H2O वॉटर आणि मला मिळणार आहे R बॉन्ड C डबल बॉन्ड OH, R bond C double bond OH, and along with water there is formation of aldehyde. But we have studied in alcohols that aldehydes are the compounds in which at least one CH bond is present. This is aldehyde. Again I will tell you, aldehyde is the compound in which at least one CH bond is present and CH bond is comparatively weak. The reaction can't stop at this aldehydic level because potassium dichromate in acidic medium is very strong oxidizing agent. The reaction is continued till the bond between C and H breaks up, oxygen gets inserted here and you will get R C double bond OH. Now the compound is very well known to us. It is carboxylic acid. It is carboxylic acid. आपण त्याला लक्षात घ्या. आपण बऱ्याच acidified dichromate प्रॉपर्टीज बघितल्या. आपण acidified dichromate as good oxidizing agent कसं काम करतो ते बघतोय. 4 केमिकल रिएक्शन्स इनऑर्गॅनिक सेक्शन मधले बघितले आपण. Fe2+ चं कन्वर्जन Fe3+ मध्ये करायचं त्या वाल्या. आणि आता मी तुम्हाला दाखवते की इन ऑर्गॅनिक केमिस्ट्री हाऊ कॅन वी यूज acidified dichromate. फॉर यूज ऑफ acidified dichromate मी प्रायमरी अल्कोहोल घेतला होता इथे. Primary alcohol in presence of acidified dichromate पहिले आम्हाला देणार आहे aldehyde, but aldehyde being very reactive compound, very susceptible compound to oxidation, the bond between C and H breaks up and there is formation of carboxylic acid. तर हा एक टाइप आहे किंवा हा एक रोल आहे की ज्याच्यामुळे आपण प्रायमरी अल्कोहोल्सचं ऑक्सिडेशन करू शकतो. तसंच तुम्ही सेकंडरी अल्कोहोल्सचं पण ऑक्सिडेशन ॲसिडिफाईड डायक्रोमेटने करू शकता. समजा मी एक सेकंडरी अल्कोहोल घेतला, हा जनरल फॉर्म आहे सेकंडरी अल्कोहोल्सचा. when the secondary alcohol undergoes oxidation in presence of acidified dichromate, the bond between CH and OH breaks up. OH, loss of water will take place. Ketone will form along with water as a byproduct. So these are the chemical properties of potassium dichromate. Potassium dichromate, being good oxidizing agent, can be used in number of chemical reactions. ठीक है.